Here's a part model designed using SOLIDWORKS. The intent is to machine the part from 6061 aluminum. This part will require 7 setups on a 3-axis CNC machine, or using a 5-axis CNC, this part could be machined in a single setup using indexing or 3+2 machining. Let's use the integrated SOLIDWORKS CAM by CAMWorks to program this part. I'll begin by extracting the machinable features on the part model. SOLIDWORKS CAM can automatically recognize over 20 different types of machinable features and add them automatically to the feature tree. Here you can see all 7 setups have been created, and the features from each setup have been recognized and automatically placed under each setup in the SOLIDWORKS CAM feature tree. Next, I'll generate the operation plan, and SOLIDWORKS CAM will automatically generate all of the operations required to machine the features using knowledge-based machining. All of the operations are now created and have been added to the SOLIDWORKS CAM operations tree. Next, we can generate the toolpaths for the operations, and all of the toolpaths are created automatically. Each operation can be opened and reviewed. Any desired changes can be made to the operation parameters and saved back to the database, so the next time the operation is generated, it will include any desired changes. Now that all the features and operations have been generated, we can use toolpath simulation to simulate the machining of the part. SOLIDWORKS CAM simulation displays each of the operations that will occur on the CNC machine in the order listed on the operations tree and performs collision detection on the tool, tool holder, and stock. Once the simulation is complete, I can use the compare feature to compare the machined model to the design model for accuracy. I can see the part has been completely machined except for the surfaces in the center of the part, which will program automatically later using tolerance-based machining. Now that the part has been programmed, I can post-process the data and generate the G-code program required to machine the part on the CNC machine. I'll give the file a name and then generate the G-code for machining. Here you can see the G-code program being post-processed. Next, let's take a look at the tolerance-based machining, or TBM automation, included in every seat of SOLIDWORKS CAM. We'll begin by setting a tolerance range from 0 to 0.1 millimeters for whole features and select a precision machining strategy for the MBD tolerance range. Using TBM, users can define multiple tolerance ranges for different types of features and select the machining strategies required to meet the tolerances specified by the MBD data. On the Surface Finish tab, we can assign a color to each surface finish range, and the color will be assigned to each surface that falls within the specific range. We can also assign the correct machining strategy to meet the surface finish requirements when TBM recognizes each surface finish symbol. Next, we'll use automatic feature recognition to extract the machinable features on the part, and TBM will read the MBD data and assign each of the colors and machining strategies we specified under the TBM settings. Now we'll generate the operations for machining using knowledge-based machining, and thanks to TBM, the assigned strategies will create the operations required to meet the tolerances and surface finishes specified by the MBD data. Now that all the operations have been generated, we can generate the toolpaths for machining. Once all the operations have been generated, we can use the integrated simulation to verify the toolpaths for machining. Here you can see the simulation of each of the surfaces being machined. And when the simulation is complete, we can use the compare feature to compare the machined model against the design model to see that everything is completely machined. Once we're happy with the machining process, we can generate the G-code for the CNC machine to machine the part. I hope you're beginning to understand how MBD data and tolerance-based machining can help you reduce programming time and improve the quality of your parts. And when you're ready to move to the next level, CAMWorks can be used to program even the most complex parts, including 3-axis molds and more. Here, using CAMWorks, a 3-axis mold for a PVC fitting is programmed in less than 5 minutes. And when a change to the inlet dimension of the part from 30 millimeters to 25 millimeters occurs, the mold updates automatically. Because the CAD and CAM files are one and the same, CAMWorks recognizes a change in the mold has occurred, and the fully associative toolpaths are automatically regenerated. Within seconds, the toolpaths are updated and a new CNC program can be created for the new revision of the part. Using CAMWorks, even the most complex parts on the most complex mill-turn machines can be programmed easily. CAMWorks can take advantage of the full capabilities of your machine so you can get the most out of your investment. Even the most complex 5-axis parts can be programmed using CAMWorks. Impellers, blisks, ports on cylinder heads, and more can all be programmed. And using CAMWorks Virtual Machine, you can leverage true G-code simulation to prove out your programs and reduce setup time. And perhaps most importantly, during this time of crisis with COVID-19, SOLIDWORKS, CAMWorks, and CAMWorks Virtual Machine enable the designer, CNC programmer, and CNC machinist to all work remotely and seamlessly so production can continue.